Today we will talk about dynamic memory allocation in C and how pointers need to be used when doing dynamic memory allocation. So it will be pointers and dynamic memory allocation. So what is dynamic memory allocation? It is the allocation of memory to certain data type, some variable, creating a variable, but that assigning of memory should be at the runtime. It should not be at compile time. So we have to do some we have to write some code that will do the required job at runtime instead of at compile time. So for example, I have an array. I want to create an array, and we know that when we compile the program, the array is allocated as size. So if I write int, then an array A and 100 here, when I compile the program, the an array A will be created and memory will be allocated for this array. And obviously, how much memory will be allocated? It will be 100 for 100 integers. Fine, the 100 and whatever an integer takes on the compiler, that will be multiplied. But we know that this is not a good method because say in the future we only need to store 10 numbers, so remaining 90 positions will remain wasted. So it is better to delay this allocation unto runtime. At runtime, ask the user how many numbers he wants to store, then allocate the memory. That is, this will be a better method. So for that we use dynamic memory allocation. What is the function for that? We just have to write a function called malloc, malloc. So this function will do the allocation, and this function you just need to give it how many bytes you want to allocate. So the number of bytes needs to be put here inside the malloc. So if I want to allocate 20 bytes, 16 bytes, or like that, obviously it will not be 20, it will be 8 bytes or 16 or 32. Then that thing needs to be written here. And this malloc function obviously will need a header file in which it will be there. So the corresponding header file is hash include conio dot sorry stdlib dot h. So this is the header file that is required for malloc function. The definition of malloc is inside this header file. Okay, now what size we need to allocate, that we will take from the user. And whenever we allocate a memory, this memory will obviously be allocated in will for example be allocated in RAM, and we need a pointer to that memory. How will we access that memory? Memory is allocated, fine, but how will we access that memory in the future? We need a handle for that memory, so we must put a some pointer here, maybe p for example, that would point to this memory, so that in future we can use this allocated memory. That means we initially need to make a pointer. So int star p, we created a pointer, fine. This pointer will be used to point to that allocated memory, good. And we also need to ask the user that how many numbers are there in the particular array. So we should write for example int n. Then we may ask the user enter the number of elements in the integer array. So take that thing from the user, put that in n. Right? Now we know that the user, and when will we know this? At runtime. At runtime, the user will tell me that I want to store, for example, 7 numbers. So n will be 7 at that time, and accordingly I will assign memory for 7 things. So if we have 7 integers, how much memory I require? How many bytes I require? I will require 7 into the size taken by an integer. So the size taken by an integer, I can easily calculate using another function called the size of. So since I have to find the size taken by an integer, just call the function size of int. This function will return the number of bytes that one integer takes. Fine. But we don't have one integer, we have n integers. So just multiply this with n. So if the user says 7, so 7 into the size depends on the compiler. This compiler uses 4 bytes for one integer. So it will be 4 into 7, that is 28 bytes will be allocated. And out of those 28 bytes, the first byte will be pointed by p. Now we have a p thing, we can use it in for further processing. So we are done. We have a pointer, and this pointer is of integer type. So it is pointing to a memory of certain bytes. Now what I just, so this line is dynamic memory allocation. By this line, dynamically memory will be allocated. At runtime memory will be allocated. Now I want to enter those n values. Fine. So I will write printf, enter the elements. Fine. Enter the elements of that array, and since this is an array, we obviously need a loop to enter the elements. Array starts from 0. It will go to I will be less than n and I plus plus. Fine. This way we enter an array, and we should write here int I. Okay. Now scan those n things. Scanf, then percentage d, because these are integers. Okay. And what should I write here? What is to be scanned? I obviously here do not know the name of the array. I have not given any name to that array. The only thing I know is p, that the first location where I have to store these elements is p. So I just will write here p. No need to write ampersand p, because p itself is a pointer. And this way the first element that will come in from the keyboard will go at location p. Fine. Okay. And when this loop will run again, we want next element to go to next location. So I must write here p plus plus. When the first is done, then there will be an increment in p. P will go to next position, and the next element will be entered. Fine. So it will be something like this. Let me show it here. Say for example, the user says n equal to 3. So what will happen? An array of size 3 will be created. Fine. And since the p is pointing here, so the p will be pointing to this first location. Okay. Now when I run this loop, the user enters a value. For example, if the user enters 2, it will go to this location. Then I want the next value to go to this location. That is why I have to write p plus plus. P plus plus means the pointer will point to the next location. So now the pointer will go to this location because of p plus plus. Okay, and it will not be here. Now the pointer will point to this location. Loop will run again. The second value will be input from the keyboard. That value, for example, if the value is say 3, so that 3 will go to this position. And then again a p plus plus, so p will move here, fine, and the loop will run. The loop will run, and the next keyboard entry will obviously go here. Say for example it is 1, so 1 will go here, and then there will be again an increment in p. So again this p will move up to here, next position. Since the value of n was 3, loop will run only thrice, and the final thing will be like this. So I will have an array with 3 elements and p is pointing here after the array. Now if I tell you that just print this array, so again I do not know the name of this array. The only thing I know is p. If I start printing the array using p, what will happen? P will print this thing, some value which will be here in the memory, which obviously is not our concern, which should not be printed. We have to print 2, 3 and 1. That means we have to start printing from here, but p has reached here. How to solve this problem? We can solve it easily. We can say when p was here, we can put another pointer here. Using that pointer in future we can do the printing thing. So for example here, when we created p, we can create another pointer, for example q, which will point to p, which will point to the same location as p, fine. And we need to write it here also, right? Pointer q. We just repeat, it will be like this now. So this will be q. After the scanning has been done, p will reach here, but q obviously will not change its position. Now we can use this q to print this array easily. We just have to run a loop 0 to less than 3 and increment the q for printing purposes. Q will, when we print this value at q, 2 will be printed, then we may increment the q, then 3 will be printed, we may increment the q, then 1 will be printed. This can be written like here. So for printing the values, we can write here printf the elements of the array are, fine, elements of the array are, then we use for loop, again I equal to 0, I less than n, I plus plus, fine. And then we can use this q for printing. So printf percentage d, what is to be printed? We have to print not q, we have to print the value at q. So the value at q means star q. Star q means the value at q. So the value at q will be printed. This way we can create another pointer which can be used for printing purposes, displaying purposes. And another good thing with this dynamic memory allocation is that at runtime we can deallocate also the memory. So I can write these, call this function free p. Free is a function which deallocates the memory that was allocated to p, and we can also free q. the memory, if there is any, allocated to Q, right? So actually we have allocated memory to P. We need to necessarily deallocate this thing. This is this, and if we don't want to use it, and if even if we don't deallocate it, it is okay. But to save memory, we can use this free function, and this deallocation is done. And I have added Q++ here because we need to do the increment. Now let us execute this program and see what are the number of elements in the array. This is 3, so 2, 3, let us say 2, 3, 1, and it is printing them rightly. And you can see it took some seconds to do the deallocation part. Then after printing this, it deallocate to the memory. And this is how we do dynamic memory allocation. And this same thing can also be done for strings. And let me show you for the same thing for strings also. So what can we do? Let me manipulate the same program, and let me say I have to enter a string from the user. Fine. So if I have to enter a string from the user, it will be char. Fine. And the string will have certain size, let it be n. For if we want to run a loop, let it be I here. So I ask the user enter the size of the string. Fine. So the user will tell me what is the size of string. I took it in n. Done. Then I allocate a memory malloc size of, since this is a string, so it will be size of char into n. Done. This is also okay. Now I will ask here enter the string. So I will ask the user to enter the string. For entering the string, I may just write scanf, right? Scanf for entering the string. I may use other methods like fgets also. So percentage s. What is the string? The string is to be put in a memory which is pointed by p. So when we don't need a loop here, obviously. We will ask the user enter the string. That string will directly go to this memory which is allocated by p. Fine. Percentage s means the string. Once we have the string, we have taken the string, then we can just print that string. So you can write here the entered string is, and to display a string there are multiple ways. Either we will just write here, uh, we use printf, we use puts, many other ways, but here we are using a pointer, so we can do the printing part using the pointer thing itself. So I may start, if the length of string is n, I may use this logic, right, to print the contents of that string. And there is another way also. Instead of a for loop, I can use a better method. I can use a while loop and write here that just display the value at q, keep on doing this, and a time will reach when q will point to \0. You just stop at that position. So when this q reaches \0, I have to stop, and if it doesn't reach \0, then all is okay. You just keep on carry on doing the things. So this will be the loop. So instead of a for loop, I can just write a while loop where I am saying that this loop will run to the point unless and until we don't reach this \0, because a string is always terminated by a \0. Since this is not a normal array, this is a string, so there will be a \0 at the end. So for this type of printing, we don't even need to know the size of string. We just write \0 and the string will start printing unless and until \0 is not reached. Fine. So let us check this program, save it as, and just run it. Enter the size of the string. So for example, size is 5. Enter the string. So say hello. So the enter string is fine. We need to make some correction. I think here, obviously this is %C. So this is not D. This is %C, because I had written D here, that it was printing the ASCII value of corresponding ASCII value. Let me run it again. Say for example 5. Say hello. So the enter string is hello. And if I don't want to keep the space there, I may remove the space here. Run it. 5 hello. So it has printed hello, and now it is doing that free thing, free p. It is freeing the memory that has been allocated to p.